I don't plan to live beyond 100 years of the length of the study, so I'm going to see how much I can get done now. So let's start with why I'm here. I'm here because the organization I work for, OpenAI, has some slightly strange goals. Our goals are mostly to make sure that the sort of AI progress that we're seeing now is ultimately beneficial. And the sort of work I do is mostly in the policy domain. Like, I talk to governments and I try and work out what are things that governments can be doing to lead to better outcomes. And what I've ended up with is an idea that maybe measurement is the thing that we need to think about to help us be more prepared as a society to deal with the impacts of AI. And why do I think this? Well, I think that measurement drives forecasting, and forecasting drives policy decisions. And if we have better measurement around us, we can make better forecasts, and if we can make better forecasts, we can ultimately do smarter policy. So I'm going to give you a very, very quick overview of some very basic elements of recent AI progress. Then I'm going to talk about some of the more specific measures which people in the sort of AI community are looking at these days. And then I'm going to talk about all of the reasons why measurement is actually a bad idea and may not work at all, just to prove that I'm trying to be honest with myself about my argument. So where are we today? A couple of just really obvious graphs. One, in terms of speech recognition, we've crossed over some kind of nominative human barrier. And all that really means is that speech has got good enough that we can deploy it widely in systems like Alexa or Cortana or Google Home or what have you. Similarly, for image recognition, we have a similar thing where we've gone past some notional level of human performance. And what that has meant is that we now have systems around us that can sort of categorize the world and scan it and lead to interesting economic activity. However, I think that era of having simple measures which we could look at is actually over. And we had this nice honeymoon period where we had simple metrics that we, as a kind of research community, could optimize for. And now we're in the domain of much more specific things with more specific purposes. So as an example, here's a language sort of testing system called Squad, which some people like. Squad is basically a way to present a chunk of text to an AI system, have the AI system churn through it and answer some questions about it, which requires the system to have read the text and mapped some kind of longer range correspondences within it. And when you model progress on Squad, you see something similar to what you saw in image recognition or object recognition. You see an encouraging rise towards some level of human level performance. This data is all from last year. And then if we look at data on Squad from this year, what you see is that all of the stuff in red is now beyond human performance. And I think that this is actually a problem because it shows that we're developing these more specific measures or more specific tests, but understanding what that means in terms of a holistic, general sense of progress around AI is kind of tricky. These are like point solutions with very specific purposes, and we may be blasting through these at such a fast rate that we may not even be measuring or testing the correct things. And so why I'm telling you this is that I think that we're moving into an era where we need to measure multiple different aspects of the technology to sort of think holistically about it. And simple measures like speech recognition or image recognition aren't really going to suffice anymore. We'll need to think about other things. But when you go to a more specific test set or a more specific way of thinking about data, you run into problems. So what can we instead think about measuring that will give us more of a sense of where AI is going in the kind of true existential sense? I think that one good candidate for stuff that we know we can't currently measure today but would like to is essentially fake imagery. I think that everyone has a pretty visceral reaction when you look at stuff like this because you can see that our ability to generate fake images that are convincing has got really, really good. The problem is that we can't measure this in a particularly disciplined way. Like, you can show these pictures to a bunch of people and ask them how real they look, but it doesn't really lead you to something that you can plot easily on a graph. And I think that the lack of being able to quantify this is actually problematic because it means that we have a hard time placing ourselves within this sort of phase of progress and understanding what it means. And why do I think that we should have better measures here? Because I think that this technology leads to people developing technologies that will kind of change society in quite sort of significant ways. So this just came out a couple of weeks ago, and it's a way to sort of have me operate another puppet, like in this case, former President Barack Obama. And by being able to operate this person, I can do interesting synthetic imagery, and the sort of effect of this on the world is going to be like ruinous and weird, right? You're gonna have a completely changed information environment that you inhabit. You're gonna not understand who's real or who isn't. I'm gonna spend a lot more time on planes so that I can verify that I've spoken to someone in person because I can no longer trust the visual world around me. And the fact that I can't measure this in a more disciplined way is actually a problem, because this is the sort of thing that policymakers intrinsically care about knowing. And it's the sort of thing that policymakers really don't want to get surprised by. So we're kind of heading by default now to a situation where someone will make like some fake news with some fake politician, and it will create a series of problems, and then the politicians will ask us, why didn't you tell us this was coming? And we'll say, well, we didn't quite know how to measure this, and so we didn't have an easy way to articulate the kind of risk that you're facing. So I think that that's an important motivator. Another nice example is progress in things like drones. I think that drones are amazing technologies which are going to have huge economic effects, but again, we can't really quantitatively model the rate of progression in drones because you use different sort of testing infrastructures, you examine them in different ways. And just as this example, here's someone who trained a drone last year in simulation to sort of land, and that's fairly impressive. They sent me an email about it, and because I'm an unsympathetic and unpleasant person, I've sent them an email back saying, I don't believe that this is that significant because you haven't done it in reality, and until I see you doing this in reality, I don't trust that there's real progress here. So they wrote me an email a few months ago saying, well, thanks to some stuff that OpenAI did, I figured out a way to make the drone work in reality, and they sent me a video, which I thought was useful. This makes me really nervous, actually, because we as OpenAI have like created a technology that has let someone do good research and make a drone do something vaguely interesting in the real world, but our inability to track this stuff at all at the sort of object level means that my sense of progress in this domain is just from me sitting on the internet and like analyzing progress in a subjective manner, and I think that isn't particularly great. So why do I think that disciplined measures of sort of measurement are actually useful? Well, here's an example from OpenAI. OpenAI has a competition based around generalizing into different levels of Sonic the Hedgehog. The idea being you train an agent to play Sonic the Hedgehog, and then we test it on levels it's never seen before. And if it does well, we know that you've had some kind of progress. When we were first analyzing the progress here, we simply charted the performance of 3 different algorithms, and then we were sort of staring at this. But I don't feel that this graph actually helps me understand the problem that we're trying to solve in the slightest. I just have graphs going sort of up and to the right. So what we did then is we did a variant where we trained 2 of these algorithms in such a way that they'd need to be doing transfer learning, and now I have a slightly better sense of progress here, but I don't really know what it means. Like, I don't know where to place myself within this graph to understand what the sense of progression is. So what we ended up doing is getting a bunch of humans to try and do the same task we had the AI do, and we're able to produce this graph. And I think that this is intrinsically useful in a way that the other graphs aren't, because now I understand like what a human can do, and I understand where our algorithms are on that lens towards it. So those are my cases for like why measurement is actually useful and why I think it has good effects. Now I'm going to give you a few reasons to not trust anything I've just said. So measurement is kind of pernicious in the sense that what you really want is to get a graph going up and to the right, and what you actually get is behaviors that aren't quite right. So here's a boat that's meant to be completing a race, and you know, it gets amazingly high scores and does well. This is a boat we trained at OpenAI. You may notice it's setting itself on fire, which isn't super promising, and it's not actually completing the race. And that's mostly because the points it's accruing from those boxes we thought correlated to actual performance of the general algorithm. It didn't. It just means that it's gathering points. And that leads to you kind of sitting there and thinking to yourself, this is fine, surely there's some kind of sense of progress here, but maybe it's sort of illusory. Another good example of this is with the zooming in on the retro contest we just spoke about. You have Sonic doing really, really well here. This is from the top performing thing on the leaderboard. But when you go and take a closer look at what the performance is of that thing, you'll see that it gets to a particularly tough point of the level and works out how to glitch its way through the entire level, which is good, but it's not actually what we wanted at all. Here's a third example where we have a robot, and the robot's goal in life is to move that green puck to the red dot. And what you'll notice is that the robot just learns to move the table, which is like incredibly dangerous and unpleasant and difficult and not something I want to actually experience in the world. So in closing, like, why do I think any of this is a good idea at all, and why do I think, despite these problems, you should actually think about measurement as something to do, and why I'm going to be uncharacteristically optimistic? Well, I think that the kind of default state of the world is increasing levels of aggression as countries try to do national-level AI initiatives, and they're going to compete with each other on various sort of subjective models of what their other country is doing, and that's because we haven't motivated them to think of AI as like a global-level solution to global-level problems. If we're able to create a way to do more and better measures of AI and its progress and its impact, then we can reframe the kind of international geopolitical discussion from countries competing with each other to countries being sort of motivated by wanting to do well on similar sets of measures. And what I mean by that is I would like America and China to get caught in a competition with each other to see who could do better low-cost health diagnosis via AI at a global level and compete on that measure. Or I would like them to compete on ways to do sort of climate recovery or flora and fauna stuff or wildlife management. Whether this can happen or not is sort of up to us. So thanks very much.